point is that 1 meter is the same as 100 cm, as we all know. Then volume, 1 cubic meter is actually 100 cubic centimeters. So that gives us 1 million cubic centimeters. Compare this with our area. You have space in your notes, just put it down as a reminder. Versus area, 1 meter, same thing, 100 centimeters. 1 square meter, how many square centimeters? Do you remember this? Even if you don't remember, you can see the pattern, right? 1 meter, 100 cm. 1 cubic meter equals 100 centimeter cube. So for area, we are going to square it. We are going to square 100 squared to give us 10,000 square centimeters. Okay, I was telling my previous class, I do not ever want to see this. 1 square meter equal 100 square centimeter. Wow, 1 cubic meter equal to 100 cubic centimeter. Do you know the difference? Do you know the difference? How big a difference it is? Let's visualize. Can you imagine a cube that is 1 cubic meter? What does a 1 cubic meter cube look like? What are the dimensions? One meter, right? Okay, so about this height, that is 1 meter. This is the height of the cube. Then the length, 1 meter. Then imagine a cube that is this big. 1 by 1 meter by 1 meter by 1 meter. That's a lot of water, isn't it? Can you imagine? Can you imagine carrying this? Cannot, impossible. Okay, maybe very, very strong hand. Otherwise, 1 cubic meter is a lot of water. Now, you compare that to 100 cubic centimeter. Do you know how much that is? How much is it? 100 cubic centimeters. Is this something that we can visualize? No. Very simple. Look at a water bottle. What is the capacity of your water bottle? 2.5 liters. Wow. Okay. Very big. No, I don't think it's 2.5 liters. No, it's less. Less than 2.5 liters. Why am I so sure? Because you know your big bottle of Coke. How many liters is that? 1.5. It looks about the same size now. Okay, so that can't be 2.5 here. 1.5 liter is this big. 1.5 liters is 1,500 ml, isn't it? Right? And this is just 100 cm cube. That must mean that 100 cm cube is way less. In fact, your little mineral water bottles. Hey, let me see this. This. This is 500 ml. 500 cubic centimeters. 100 cubic centimeters is just a little, 1/5 of it only. Now, can you imagine this 100 cubic centimeters versus that 1 cubic meter? That's a big difference. You can never say that they are the same. They are way different. How different are they? Well, 1 cubic meter is supposed to be 100 centimeters cube. And now this will give us 1 million cubic centimeters. That is how different they are. Okay. Okay, so fill in the rest of the blanks. 1 cm is 10 mm. So 1 cubic centimeter will be 10 to the power 3 mm to the power 3. You're just cubing everything. Okay, fill in the blanks. The rest are self-explanatory. Just remember, you learn in primary school that 1 ml equals to 1 cubic centimeter. Because sometimes you'll include liters and milliliters, and you are expected to know the difference. So now, 0.007 cubic meters in cubic centimeters. How do we do this? How do we actually go about doing this? Okay, I'll remove all this first. Cubic meters change it into cubic centimeters. If the cube didn't exist, is it a very simple question? If the cube didn't exist, so let's say 0.007 meters to centimeters, very easy, right? What do we do? Multiply by 100. If the cube didn't exist, we just multiply by 100. But now there's a cube. Yeah, exactly. So we multiply by 100 cube. That's all. Okay, that's the only difference you have to do. Instead of just times 100, you times 100 cube, because now we are dealing with meter cube to cm cube. So we need to move the decimal place by 6 times. Times 1 million. You can either view it that way, move the decimal place by 6 times, or you can just take your calculator and multiply. Okay, so 0.007 times 1 million. You will get 7,000 cubic centimeters. Okay, so that's part A. Part B, changing liters to cubic centimeters. Okay, this one is your primary school work. I will ignore that, part B. Part C is also your primary school work. I will ignore that. You are expected to know. I don't even want to give you the answer. You should have confidence. Now part D, 0.837 cubic meters to cubic centimeters. Is there anybody who doesn't know how to do part D? If you don't know, raise your hand. I will not call you. If you put on your hands, it means that you know how to do it. Then I can call you to share your answer. Okay, part D. Anybody doesn't know? Raise your hand now. I won't call you. All can. All can do. Okay, I'm going to start calling people. Part D. Sabrina, can you help us? Part D, 0.837 cubic meters to cubic centimeters. How? Give me the method. I don't want the final answer yet. Sorry? What is it? Multiply by 1 million. Is it? Okay, correct. Multiply by 1 million. So 0.837 cubic meters equals to, let's multiply by 1, 2, 3, 4, 5, 6, 837,000 cubic centimeters. Simple as that. Not times 100, huh? Okay, next one. Part E, do yourself. Part F. Part F as shown. Okay, you can copy this down. There's no kick. I'm interested in part H. Okay. Part G, do as your homework. Simple. Just times 1 million only. Part H, can you use what you have learned and try and figure out what is the conversion from cubic millimeters to cubic centimeters? Is it times 1 million as well? Is it going to be times 1 million? So think about that and try it now. You have 2 minutes. So in this case, base area, we've got 2 square. That is the square. Plus half times the base. The base of this triangle. 5 minus 2, we get 3. And the perpendicular height, 2 plus 2, 4. This is our base area. So 4 plus 6, we get 10 square centimeters. Okay. With this, now I write down the volume. Volume is our base area times the perpendicular distance 3.2 to give me 32 cubic centimeters. That's part A. No, they didn't quite pay it. So that's just the volume. Total area will be, Aiman, you are expert at that already. What is the total area? Two plus 2 plus 5 plus 5 plus 2. Okay, then what do we do? Times how much? Don't you need to multiply this with something? Perimeter times something, remember? Come on, perimeter times the perpendicular distance. What's the perpendicular distance? 3.2. Okay, then we need to add 2 times of something. What is that? 2 times of what? 10. Good. Okay. So 2 plus 2, 1, 2, 3, 4, 5, 8. Oh, no. There's an error in the perimeter. 2 plus 2 plus 5. 2 plus 2 plus 5 plus another 5. 8. Oh, yeah, correct. Sorry. 2, 2, 2, 5, 5. Okay, correct. So this gives us 16 times 3.2 plus 20. 71.2 square centimeters. That's all. Okay, so what is the advantage of writing out the base area first? As I've always been telling you, the advantage is that we use the same base area in 2 ways. Our 10 is used in our volume, the same 10. At the same time, it is used in our calculation of total surface area. Now imagine if you did not write down the base area at your first step. Instead, you chose to multiply everything to find the volume. That means you write 2 square times plus half times 3 times 4, then you times 3.2, 1 line to get the volume. Then the next step, when you have to find total area, you still need the base area again. Then you're going to be repeating the same calculation. Waste time. Worse, if you make a careless mistake, go on. Or if you did the total area first, you will still need a base area, which is used in our volume. Might as well as a standard practice, write down the base area first. And that is what we are going to be doing for the rest of the questions. So question 3, try it now. Identify the base